Hi, I'm an old guy and I do maths, and today we're looking at rationalising denominators. Now, this pertains to surds. As you can see, there are a couple of surds on the page. There's another one further down the page. And what we're looking at doing is we're looking at turning the denominators of what are essentially fractions into rational numbers from surds. Surds are irrational numbers. Basically, we're looking at getting rid of the square root sign. And this is how we go about it. What we do in this case is we take the denominator and we multiply by the denominator, root 2 by the denominator. Basically, this is 1. Anything divided by itself is 1. So essentially, we're multiplying this fraction with an irrational denominator by 1. And we get 3 root 2 over, I'll do this longhand, we get 3 root 2 over 2 times 2, root 2 times root 2, which is the square root of 4, and we end up with this. This is the same as this mathematically. It has the same effect, it has the same value, but it's got a rational denominator. So let's just talk through that process again quickly. This is a very simple fraction. So we take this denominator and we create a fraction out of it. Root 2 on root 2, which is the equivalent of 1. And we multiply this by this. And in so doing, we get 3 root 2 over root 2 times 2, which is 3 root 2 over root 4, which is 3 root 2 on 2, which is our answer. Okay. Something a little more complicated. I'm going to do this the long way. There is a shortcut which I'll show you afterwards. Okay, so what I'm going to do, just for the sake of continuity, is I'm going to take the whole denominator and multiply. That may be a hint about the shortcut, but I'm going to do what I did up here. So that is 10 root 2. 5 times 2 times root 2. This, from the multiplication of surds, which hopefully you know about or you've seen a video, hopefully my video, 2 times 2 is 4, and we'll do this 2 times 2 in there. So tidying this up, we've got 10 root 2 on 4 root 4. Okay, so what can we do? Well, we can tidy this up. We get 10 root 2. 4 times root 4, the square root of 4 is 2, so this expression is 8. It's 4 times 2, which is 8. And now we can do a little bit of tidying up here. 2 goes into 10 5 times and into 8 4 times. So our answer is 5 root 2 on 4. Okay, so that's this somewhat simplified. Now, A faster, slightly faster way would have been to not include these 2's. So I'll just do that quickly. I'll just get myself some room here. So what was it? 5 on 2 root 2. And I'm going to multiply that by root 2 on root 2. So basically the only thing we're interested in doing is getting rid of this surd. I simply did it this way because there was a degree of continuity with the first one. But here's the quick way of doing this. We get 5 root 2 on 2 times 2 times root 2, sorry, 2 times 2 times root 2 times 2. Say it more slowly and you won't make a mess of it. That's 5 root 2 over 4, which is the answer that we got here. Okay, so that's where you've got a denominator that's basically one expression. Now, as you can see, as I move down the page, I've got an expression here where the denominator is made up of 2 parts, and this makes things a tiny bit more awkward. Now, what we're going to do is we're going to do something that looks a little strange. We're still effectively multiplying by 1, as we did here, as we did here, and as we did further up the page. But note that we have changed the sign. And what we're relying on here is something from the expansion of quadratics. We're creating a quadratic that is the difference of 2 squares. So just let me deal with the numerator here. So that's 3 times 2 minus 3 root 5. So that is 6 minus 3 root 5. And the denominator I'm going to do down here. So we've got 2 plus root 5, 2 minus root 5. Now this should be starting to look a little bit familiar. So 2 times 2 is 4. 2 times negative root 5 is minus 2 root 5. 2 times positive root 5 is 2 times positive root 5. And root 5 times negative root 5 is negative 5. So what we wind up with is 4 minus 5, which equals negative 1. And that is our denominator. Now, this is untidy, and we don't need to have negative 1 as a denominator, so we can simply rewrite this as 3 root 5 minus 6. These two negatives make a positive. This is a positive divided by a negative, so it becomes negative. That is our answer, and that is how you rationalize the denominator of a surd that looks like this. I hope that was helpful. It looks a little bit untidy, and I apologize for that, but I am a messy worker. What can I say? I do my best. See you later. Thanks for watching.